The Ilham Tower, also known as Ilham Baru Tower or IB Tower, is one of the tallest skyscrapers in Kuala Lumpur, Malaysia, standing at 274 meters tall with 60 floors, 4 subgrade and 5-story podium. Occupying approximately 93,000 square meters, it is a commercial residential building with 33 floors for office and 22 for apartments. Featuring postmodern architecture and distinct diamond-like form, the project was initiated in 2009 by IB Tower Sdn Bhd, with design contributions from Foster and Partners of London and SA Architect Sdn Bhd. The project involves several key stakeholders: IP Towers Sdn Bhd, the owner, established objective, providing funding and enforce regulations. Foster and Partners, as the design consultant, ensure the design meet aims and requirements. TY Link International Sdn Bhd handled civil and structural engineering, while Juruterra Perunding Walden Sdn Bhd took care of mechanical and electrical engineering. And for Daewoo Engineering and Construction Sdn Bhd, the main contractor oversaw construction, hired subcontractor, and ensured the project was complete on schedule and within the budget. Now, we move to the second building, which is MRT at Bukit Bintang. MRT Bukit Bintang is a significant infrastructure project in Kuala Lumpur, Malaysia. This project aims to enhance public transportation and accessibility in the city. It is a part of the larger Klang Valley MRT, which strives to reduce traffic congestions and provide the public with easy access to efficient transportation. Bukit Bintang, a vibrant business and leisure district, is where the new metro station will be built. This station will connect major areas like the Central Business District, shopping areas, hotel, and other business districts. The MRT Bukit Bintang involves several key stakeholders, each with specific responsibility. The Mass Rapid Transit Corporation Sdn Bhd, MRT Corp, oversees the entire project handling, planning, scheduling, stakeholders, interaction, approval, and ensuring compliance with the transportation goals and regulations. MMC Gamuda KV MRT Sdn Bhd managed the construction process, focusing on tunneling and stations construction. Government agencies like the Ministry of Transport Malaysia and the Land Public Transport Agency (APAD) oversee policies and regulations, while Kuala Lumpur City Hall (DBKL) ensure local compliance with zoning, planning, and municipal laws. Rapid Rail Sdn Bhd will manage the operation and maintenance of the MRT station, ensuring smooth and safe operation for commuters. The successful collaboration of these stakeholders is essential for the project effective development and operation.
Method of basement used for our first selected building, which is Ilham Baru Tower, is semi-top-down method. Firstly, the soil above the substructure middle floor are dug using the bottom-up method during a semi-top-down excavation, and the middle floor is subsequently followed to be cast. Soil removal continues until the final level, until the poor middle floor has been solidified. Next, since the higher pit is excavated from the bottom up, the semi-top-down method takes less time compared to the top-down method. However, due to the hard middle floor being cast before the lower pit is excavated, the semi-top-down method supporting system is different. And lastly, during semi-top-down excavation, soil above the substructure middle level are excavated from the bottom up. The core floor slab is then formed. After the core slab has dried out, the dirt is taken out to the final stage, and the foundation slab and other underground building components are cast. For the next selected project for basement method, which is MRT Bukit Bintang, is utilizing top-down construction method. Initially, piles are drilled into the ground to reach the bearing stratum using traditional drill shaft or slurry trench procedure. Then shafts are concreted up to the bottom of the basement to form foundation piers. Retaining wall is installed before the excavation works begin. When excavating the basement from above, concrete slab operate as lateral bracing against the perimeter wall structure. The ground level and the first basement slab have been poured, with access hole left for excavation below. Once the subgrade level is completed, the floor serves as lateral bracing against the perimeter wall system. Next, roof slabs is constructed with the opening access provided for working spaces purpose. The construction for the next level downward can be started after the subsequent slab is constructed. Prior to the sealing the roof structure, the side wall are being erected upward and followed by the removal of intermediate strut. And lastly, once the construction of the underground is finished, the soil is backfilled to the top strut level ahead before the strut is removed. This is followed by completely backfilling the top of the underground structure and eventually reinstating the surface areas.
Hi, my name is Nurin Jaslina binti Ahmad Yani. So I will present about the waterproofing and drainage system. So basement waterproofing is the process of making the basement leak-proof and free from the water by applying a various technique. So in this case, we will look at the Ilham Baru Tower. So the waterproofing applied is first the sheet membrane waterproofing. So the sheet member waterproofing is where the heavy PVC sheets are laid on the outer walls and under the base slabs of the basement. So this method creates a solid and a strong and durable. So next is the apply a crystalline waterproofing. So crystalline waterproofing is where the chemicals go into the concrete and form insoluble crystal which seal the water path, thus providing a long-term protection even when there is a cracking on the wall. So the use of both sheet membranes and crystalline system, it will make the basement of Ilham Baru Tower is protected against both water infiltration and any compromise of its basic structural components. So next, for MRT Bukit Bintang, so the waterproofing system used is the bentonite waterproofing membranes. So what bentonite is a clay that prove useful when mixed with soil and due to its ability to expand when it in contact with water to form a compact and waterproof layer. So bentonite has the ability to self-heal in case where there are cracks on the surfaces of concrete structure. The bentonite will expand to close up these cracks and preserve the barrier against the water. So a drainage system is used to manage the water seepage effectively and support the structure of the building well. So for Ilham Baru Tower, the drainage system used are the perimeter drainage that also known as a French drains and underslab drainage. It means the drainage system around the perimeter. So an additional to the underslab drainage is pipes laid down under the basement floor with the gravel bed. So these two drains, together with waterproofing membranes, are placed on the walls and floors of the basement that offer a several layer of protection system. So this approach does not only eliminate the problem of waterproofings, but also improve the general robustness and lifespan of the structure of Ilham Baru Tower's basement. So for MRT Bukit Bintang, the drainage system used are the perforated drainage pipes along the basement walls and underslab drainage system which put the under the basement floor so that collects water leaks and flows it towards a common sump pipe. So MRT Bukit Bintang station basement is free from water seepage due to a comprehensive drainage plan where the use of automatic sump pumps, a perimeter drains and under slab system. It is also preserving the structure as well as the durability of the building. A basement is an area that contributes to creating a low humidities and molds. So, a steam, heat, rain are the ones that bring mold into a maturity stage where it can breathe. So, it also influence on human health as a direct impact, such as sneezing, allergies, asthma, and nausea. So, to prevent this, Ilham Baru Tower apply a mechanical ventilation to achieve a good supply and exhaust ventilation. So it involves a mechanism such as a fan or blower for circulation of air, so to a replacement of indoor air with the outside air, or for removement of any undesirable gases or particles. So for MRT Bukit Bintang, they use the mechanical system of air circulation that using fans and ducts installed in the space. So next, they also apply a smoke control system. So mechanical system is providing fresh air from outside, and it will eliminating the stale air and thereby restricting concentration of pollutants and providing enough oxygen for occupants inside. So for the function of smoke control system is to confine smoke in case of fire and guarantee safe ingress.
Thank you, Nuri, for your explanation. So I will continue our presentation today for part electrical and plumbing equipment for case study Ilham Baru Tower. First of all, as we know, Ilham Tower, a famous skyscraper in Kuala Lumpur, Malaysia, needs advanced plumbing and electrical system due its to large size, building and compacted design. The power distribution system inevitably begins with the main distribution board (MDS), which serves as the central hub for distribution electricity. From the MDB, electricity is channeled to the sub-distribution board (SDBS) located on each floor, ensuring a reliable power supply throughout the building. Strategically, placed power outlets are distributed across high-density office areas to meet a variation electrical needs. For your information, additionally, specialist plugs are installed in the key section like a server's room and data center, providing a continuous power supply supported by UPS to maintain sustainable operation without interruption. The second is the water supply system or public requirement. The water supply system for this building is designed to ensure adequate water pressure to all floors and apartments, utilizing water storage tank connected to the manipulate supply pumps and employer to maintain operational pressure level throughout the distribution network, which is typically constructed from the durable materials such as steel or copper. To promote sustainability and reduce water uses, the system integrates water-saving methods, including low-flow features like shower head or toilet, as well as rainwater and grey water system to collect non-potable water for toilet flushing. These measures not only conserve water but also enhance the building's overall for sustainability. Next is about the Bukit Bintang MRT station. The Bukit Bintang MRT station is a key part of the city busy transportation network, serving many commuters and visitors every day. To keep the station running smoothly and efficiently, its electrical and plumbing system need to be well maintained. Here's simple explanation for what this system needs. The power distribution system is the backbone of the MRT system, ensuring a smooth and constant energy supply for all station operation. Transformers play a current role in this system by stepping down high voltage power from the main grid to the level that can be safely used within the station. These transformers are strategically placed throughout the system to efficiently distribute power to all the necessary areas, including lighting, electronic display, ticket machine, and audio assembled equipment. This setup will guarantee the station function, reliability, and efficiency, providing a seamless experience for commuter and visitor. And for the plumbing equipment, the potable water supply in the MRT station is certainly for cleaning restroom and drinking fountains, requiring proper installation with meter control and measure value, the connection with to the city's water supply to ensure efficient distribution. Maintaining the safe safety and fluid water supply is critical for the health and wellness for both worker and passenger. Additionally, effective stormwater management is critical, reducing the risk of flood and handling rainfall runoff, with control measures in the place preventing the water build up on property, thus minimizing the environmental impact and ensuring the station remains safety and operation during the heavy rain.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noain Sofia, and today I'm going to be presenting about problems encountered and solution for both case study regarding the topic of basement. So for the first case study would be Ilham Baru Tower, which located near notable landmarks including the KLCC and Petronas Twin Tower, so making it a prominent and well-known structure. So Ilham Tower unites a range of living and working areas into a condensed 58-story tower, 274-meter tall skyscraper plus a 4-story basement. And the difficulty in creating a design for a new high-rise project for this magnitude was relating to the big urban scale while maintaining details. So the basement is also being constructed while implementing the top-down method, which has been given to Geopancha Sendirian Berhad. So a wide range of foundation components such as draft ground walls, pile caps, basement slab, board piles and barrack piles are included in the project scope of service. Since Geopancha used the top-down construction method, it is a highly advanced technique that enables the superstructure and substructure to be built simultaneously, maximizing safety and project timelines. So using the top-down approach improve the site structural stability all the way through construction, and also lowers the possibility of ground movement and collapse. And the top-down technique also shortens the project duration and speeds up the schedule. Okay, so next, for problems encountered during the construction of basement for Ilham Baru Tower would be logistics and material management, which is there is limited storage space for equipment and materials, heavy traffic causing disruptions, and also challenges in transporting excavated materials off-site. And the next problem would be construction constraints, which is fluctuating water table and diverse soil conditions. Also includes difficulties in accurately estimating groundwater levels. So next would be the solution for the problems mentioned before. So the first one would be strategic management. So effective delivery management and just-in-time supply assurance would have been critical in Ilham's Baru situation, since large storage spaces like those found in suburban construction sites are often absent from urban environments. So systems for just-in-time delivery becomes crucial as logistics can be streamlined and on-site storage requirements reduced by the project by arranging for suppliers to deliver materials closer to the time of need. Furthermore, deliveries that are timed to avoid peak traffic periods can greatly lessen interruptions to public roads. So the next solution would be comprehensive approach to effectively manage the problems encountered presented by Kuala Lumpur's diverse soil conditions and fluctuating water tables. This involves carrying out a thorough hydrogeological and geotechnical surveys in order to precisely map soil types and forecast variation groundwater level. So next, dewatering options can be made more efficient and less expensive by using energy-efficient pumps and variable frequency drive. So next would be MRT Bukit Bintang. So MRT Bukit Bintang project had likely encountered difficulties with limited space and working area too because of its location in Kuala Lumpur city centre. So it is why a careful planning and execution would have been necessary to prevent damage due to the presence of existing structures and infrastructures. So like the Ilham Baru Tower, MRT Bukit Bintang also used top-down construction method. And in general, the top-down construction method's primary drawbacks are included like its complexity, because it can be expensive, and the basement design's adaptability and accessibility are restricted also because the layout must work with the retaining walls and the superstructure. And it also must be completed carefully and simultaneously. It makes the coordination and quality control more difficult and riskier. So there are three problems encountered while constructing a basement while using top-down construction method for the MRT Bukit Bintang, which is limited space and working area. The MRT Bukit Bintang construction would have not had enough space for machinery to move around or to store dirt that had been excavated. So the second problem would be existing structures and infrastructure. Planning must be done carefully to minimize disturbance because of the existing buildings, roads and utilities. And methods such as underpinning may be employed because it is in order to strengthen existing foundations impacted by excavation. And the third problem would be public considerations, because in a densely populated area, construction noise can have a major effect on nearby businesses and residents. So reducing noise would require the use of quieter equipment, imposing work schedules and putting up barriers. And to reduce dust pollution in urban areas, dust separation techniques like mist cannons and covered material transportation become essential. So this is all require the cost. So lastly, it would be the solution for the problems encountered during MRT Bukit Bintang construction. So the first solution would be construction techniques. So in order to improve top-down basement construction, particularly in dense urban environment like MRT Bukit Bintang, so it is good to examine the hybrid approach that incorporate diagram walls and other bottom-up construction elements for initial support, potentially reducing the need of extensive temporary shoring that can reduce the cost, and not to mention to reduce disturbance to the current infrastructure and traffic flow, take into consideration trenchless technologies such as horizontal directional drilling. The other solution would be safety and sustainability. It is to provide specialized safety procedure for working in cramped areas such as basement and trenches. And this entails having trained rescue personnel on hand, keeping an eye out for potentially dangerous gases, and providing adequate ventilation. Moreover, to reduce noise pollution in the surrounding area, make use of technologies such as sound barriers and muffled equipment. So that's all for me. Thank you.
Based on the research we have been going through, there are several part of components for both of the commercial building and project that had similarity that should be taken into consideration for future references. Firstly, both of the commercial building and project absolutely required huge amount of expenses to accomplish the final product, starting from the pre-construction, during construction and the post-construction. Since most of the commercial building and project had been constructed for such a period of time, a lot of costs had been involved during construction stages, since most of the buildings were complex and required specialized and skilled building practitioners to execute the construction works in order to gain the successfulness of those construction projects. Furthermore, most of the commercial development had been erected in minimal spaces and very close proximity to adjacent buildings. This can be seen through MRT station, whereas the location of this public transport is near to the countless mega shopping complex in Kuala Lumpur. Next, the similar location of Kuala Lumpur connects the two case studies. They are located in extremely populated urban regions that have corporate infrastructure. The placement of structure in densely populated areas presented transportation challenges affecting both on-site and off-site material delivery. Due to the limited spaces for storage, for instance, it should concern regarding the expenses for transportation costs that might be incurred since there is no proper storage to restore and secure the material, plant or equipment from the trespasser, and this will result in double handling issues that could arise as well as increase in the total cost of the project.
So in this slide, we will see the differences between Ilham Baru Tower and MRT station. So the first one is the method of excavation. Ilham Baru Tower apply a semi-top down, where due to the availability of a small working space and storage. So MRT station, the method excavation applied was the top down, since the site was located between respective structures and other interference close to these structures. So secondly, in terms of cost, Ilham Baru Tower is less costly as it does not need a rock-socketed diaphragm wall or barrette foundation. Meanwhile, for MRT Bukit Bintang station, it is costly as it requires more labours. So thirdly, Ilham Baru Tower requires more time to complete it. Meanwhile, for MRT station, it saves time to complete it because it have many labor on the site.
For effective, to construct the basement of the Ilham Baru Tower and the Bukit Bintang MRT station effectively, variation techniques are employed to enhance structural integrity, water resistance, and minimal distribution. The Ilham Baru Tower used a dragon wall, second ply walls, top-down construction, and ancillary wall to provide support, prevent groundwater intrusion, and allow simultaneous construction to above ground and pavement level. For the Bukit Bintang MRT station, method is like cut and cover, tunnel boring machine, TBMS, immersed tube, ground freezing, and jet grouting are utilizing to efficiently crack underground spaces while stabilizing the soil and managing groundwater. These techniques are selected based on project specification requirement, site condition, and the budget to ensure the structure are stable and waterproof with minimal impact on the surrounding urban environment. For efficiency, to efficiently build the basement of the Ilham Baru Tower and the Bukit Bintang MRT station, several factors are considered including speed, cost, environmental impact, and safety. For the Ilham Baru Tower, top-down construction created the process by allowing basement and above ground level to build simultaneously, saving cost and temporary support and rainwater system, minimizing environmental damage through a reduced excavation, and enhancing safety by reducing deep excavation risk. For the Bukit Bintang MRT system, tunnel boring machine TBMS expanded tunnel correction and keep costs down by making the process more efficient, while the immersed tube method reduces surface distribution and pollution. TBMS also improves safety by limiting open excavation, reducing scallop risk, and overall balancing this factor, ensuring the project meets their goals and efficiency and sustainability.
Next, I'll be presenting on the construction cost differences between two significant structures in Kuala Lumpur, the MRT Bukit Bintang Station and Ilham Tower. To start off, it is essential to understand that the depth and complexity of construction are primary factors influencing the cost of this project. So let's delve into the specific. First, excavations and shoring. The MRT Bukit Bintang Station, being an underground mass rapid transit station, require excavation to a much greater depth compared to Ilham Tower. This increased depth demands advanced shoring techniques to ensure worker safety and site stability. Consequently, more earth needs to be removed, significantly raising the overall cost. Next, we have the foundation requirements. The MRT's foundation needs to handle dynamic loads from train operation and integrate seamlessly with tunnel system. This calls for high accuracy and robust construction materials. In contrast, Ilham Tower, although requiring a strong base to support its height, does not face dynamic loads challenges or tunnel integration, making its foundation less costly. Waterproofing is another critical cost factor due to its depth and proximity to underground water sources. The MRT station necessitates modern waterproofing techniques. This includes high-performance membranes, complex drainage solutions, and continuous monitoring system. On the other hand, Ilham Tower, being relatively shallow, only needs basic waterproofing, which is less expensive and complex. Next, MEP systems. MEP stands for mechanical, electrical, and plumbing. MEP systems also contribute to the cost difference. The MRT station's MEP systems are more extensive and complex, including significantly electrical and communications infrastructure, fire safety systems, and underground ventilation. These systems are designed to meet the operational needs of a transit stations. Conversely, the MEP systems in Ilham Tower's basements are simpler, mainly supporting utility services and parking, thus incurring a lower cost. So, for the finishings, Ilham Tower only need basic finishes which suitable for parking. Meanwhile, MRT Bukit Bintang, high quality finishing such as lighting, tile floors, and accessible features for public areas. In summary, while both projects involve excavation, foundation works, and waterproofing, the MRT Bukit Bintang station's unique operational needs result in much higher costs. This analysis highlights the significant financial implications of infrastructure projects designed for public transportations compared to commercial mixed-use development. For the conclusions, as a matter of fact, the basement plays an important role as literal and symbolic foundation for the building we live in. Although they provide useful extra living space and the ability to regulate the temperature, basement design and construction must be carefully considered. Common issues include limited natural light, foundation problems, and moisture intrusion. Resolving this frequently entails adding light wells or egress windows, waterproofing, and appropriate drainage. The intended use of a basement determines its efficacy and efficiency. For storage, a simple design could work just fine. Attention to ventilation, egress, and moisture control is essential for a finished living space. In the end, a well-thought-out basement can increase the usable square footage at a reasonable cost, but a poorly designed one can cause ongoing problems and financial strain. Thank you.